Okay, looks like that's about it. Welcome to how Ironic fits into PayPal's full circle of discovery, utilizing what's in your data center. Your presenters today are members of the PayPal Cloud Reliability Engineering team. I'm Chris Crelly. You may know me on IRC as NobodyCam. I can be reached at Chris Crelly at PayPal, or ccrelly@paypal.com, or Twitter at nobody.cam.
Yeah. I am Prabhakar. You can reach me at Prabhakar on Twitter. Yeah.
The basics of our environment.
Yeah. So our environment, as in previous summits we told, we have the largest reliable private OpenStack cloud running. One of the largest, sorry. So we have around 15,000 bare metal nodes, around more than 500,000 cores, and around 170 instances. So which is actually a huge. We are having 12 zones, where meaning there are 12 instances of OpenStack running. And for this particular talk, we will see how we managing bare metals. So in our cloud, the IP assignment for the bare metals is through DHCP. And the discovery tools that we use is Ironic and Ironic Inspector. And how we are able to achieve the bare metal provisioning at PayPal is through data. We have different data sources that we read and discover stuff and then provision. So the things that we are not going to cover here is the actual Ironic, how it works, or how the inspector works. So we are going to talk about how Ironic is being used to discover nodes and other tools that we are using currently.
The mission that we had was machines provisioning machines, limit human interaction, reduce the onboarding lag, and to discover all the things that are in our data centers. Our solution, Ironic, Ironic Inspector, and 360 Discovery. What is 360 Discovery? 360 Discovery is a collection of programs designed to gather data, analyze, act upon, and report systems which are newly installed, in an error state, incorrectly installed or racked, most often miscabled, reporting specifications that do not match what we expect them, because no one's ever gotten incorrect hardware from a vendor, or systems experiencing hardware faults.
Yeah, what it really does is it deploys the newly installed bare metals to the default image. And it finds the miscabled bare metal nodes, and we are going to go through how we are finding those bare metals. And it discovers the hardware with incorrect specifications, and it locates the forgotten or lost bare metal hardware, mostly because the CMDB has it, but it's actually not seen in the infrastructure. And it detects bare metals with failures, and it creates tickets whenever there is a need for the manual intervention for cabling and stuff.
So what we came up with, or where we started in the design process, was of course a cocktail napkin. So what 360 looks like from 10,000 feet is the 360 processing unit, our CMDB, DHCP, Ironic, and a ticketing system to be able to automatically create tickets. So the sources that we actually collect data from are DHCP. So every lease for every BMC is captured. Our CMDB, linked to our accounting systems, already has information about systems that we expect to come into the data center and that should be in the data center. And Ironic, of course, has information about the nodes it has registered in it. The reality of the cocktail napkin It's a bit more complex. So here, we kind of just show a basic diagram of the systems that interact to analyze our discovery data and our provisioning systems. So with every new server that comes into the data center and existing servers as they continually refresh their leases, the DHCP server information is garnered. What we gather is MAC address, IP address, and from the MAC address we determine the vendor of the hardware because we have multiple vendor supports. We use Redis as our messaging bus system, and that interconnects all of our services. So the DHCP Collector is a small, lightweight program. This will be described on a later slide. Is a small, lightweight program whose specific job is to not slow down DHCP. It gathers that information, injects it straight onto the message bus, and that's the end of its job. The information it collects is picked up by the DHCP processor, who goes out through the BMC, either ILO, DRAC, or IPMI tool, and gathers information about the hardware, processor, disks, RAM. It also gathers health state about about the devices in the machine, power supplies, and other things like that. All of that information is packaged up into a nice JSON blob and shot back through to Redis, where it's picked up by the correlation processing unit or program. Simultaneously, the CMDB and Ironic collectors in a polled cycle are polling for changes in either the CMDB or in Ironic. We have another program, the node enroll program, which monitors Ironic, specifically looking for machines that have been tagged as ready to deploy or tagged with an error or tagged as having a failure. Depending on their actions, it'll shoot a message to the ticketing system to have someone go out and inspect the machine. If it's a bad power supply, creates a ticket to just have the power supply replaced. Really limits interaction from humans. This has improved our reliability. It's allowed us to identify machines with faults before we deploy them so that they can be repaired immediately. The same process is also used for a burn-in. So when a machine newly arrives in a data center, node enroll realizes, hey, it was just been discovered by inspector. Let's run it through a burn-in cycle where it'll run for 48 hours or more just to burn it in and see if it fails. If it doesn't fail by that point, it's marked good for deploy, and it's deployed. And just the breakdown, sorry for the busyness of the slide. CMDB Collector, a small, lightweight program, a program to pull CMDB on a timed loop, gathering information, passing it to the processor. DHCP broken into two components. The DHCP Collector, again, sole purpose is to not slow down DHCP process. The DHCP processor, because it's interacting with the BMCs, is a much slower process and can actually have more than one worker performing the tasks, pulling messages off the message bus. And it actually goes out to the machines and gathers the information about the machine and the status of the health. Ironic Collector, again, just like the CMDB Collector, on a timed loop, polls Ironic, looks for changes in machine statuses. And the node enroll program is designed to handle node deployment after inspection. It also handles ticketing. Compare the processor program, correlate all of the data gathered by the collectors, analyze, reports on what it's found, and marks nodes ready for deployment. And ticketing creates, updates, and deletes tickets as needed for the data center. If a machine is seen continually having tickets created, the hardware can be marked bad and have a vendor come out and look at it or send it back to the vendor. The operation, putting it all into action. So the DHCP server will make a request. Request is captured by the collector and then sent to the processor. Processor receives the hardware information via the receives hardware information via the node's BMC controller and sends it to the processor. I just messed that up really bad. Simultaneously, the CMDB and Ironic collectors gather information from their respective sources and feed that data into the processor. The processor correlates, analyzes the data gathered. Once the node has been analyzed, the processor can then act upon that node either by, if it's a brand new node, booting it into Inspector so that it is enrolled in Ironic, opening a service ticket if there's a hardware problem, or marking the node ready for deployment. If the node's marked ready for deployment, the node enroll program comes along and notices the node's good to go and deploys our default image onto it, at which point Puppet will pick up and assign its role and put it into action.
The benefits that we have seen so far, it's like the onboarding of the new hardware where it used to be days, but now it's like less than an hour. Because there is no manual intervention, it's all done through DHCP find. So it's within an hour, mostly. As we mentioned, the processor is in a tight loop. It finds all the faulty hardwares as quick as possible. And as the failures are detected, and they are corrected before actually making an impact to the actual infrastructure. And we have a single point to manage all bare metal hardware. We have a UI too, but we'll see like whether we'll go through that. So where we can see what is happening exactly in the infrastructure across all zones. And all the lost or abandoned hardware are rediscovered and put back to work. As he said, like the CMDB will have a data which is not there in Ironic, or Ironic will have a data where the CMDB does not have the data. So the processor will find all the abandoned hardware. So all of the above like help the company to reduce cost and increase reliability and improve the manageability of the infrastructure.
Areas we're looking to give back to the community, areas we'd like to improve others who are going on this journey, trying to automate their onboarding and provisioning, is one of the areas we found is adding system health to the Ironic node model. We have systems now that use the Ironic node extra field, which is used for a bunch of other things within our environment as well. So our node extra field is quite large. We feel that adding health checks into the node model would actually allow operators to make informed choices when they do a deployment onto that hardware. In a lot of cases, these are mission-critical machines that people don't watch. And knowing the state of the health before you put your workload on it is very important to us. And we feel it's very important to others. So that's an area we're looking back. We've actually put up an RFE. You're more than welcome to go take a look at it and comment on it. We're trying to make it a solution that it works for the entire community. Please feel free to reach out to myself. I'm in OpenStack Ironic channel all the time. I never leave. And I usually say good morning. Never say good night, but I always say good morning. So one of the things that we were looking at doing here was previewing what an interface like this might look like for operators to take a look at. We're hoping to be able to present the whole UI in the Vancouver Summit coming up. But right now we can give you a preview of what we've got, and it'll actually be live.
It's not loading.
Oh, it's on the other monitor.
See, this is the UI that like I previously mentioned, where we have the view of the whole infrastructure, meaning like all zones and everything. So due to confidential issues, I cannot go to the left-hand side tabs, but the next, see, you can see this is the real data. It's actually coming. See, I am going to cloud.paypal.com. So previously we mentioned like we are having around like 1,400 hypervisors. Here we are saying like 1,100 because this is the real prod. That includes all the dev workload too. There also we are running 2 zones where we run dev workloads. So this is the real production. So the whole thing, like how you can manage all the instances of OpenStack within a company, we will do more on the next talk, like about this UI and other stuff. Yeah, that's all we have. And this is.
Of course, it's not a single person's effort or a group effort, it's a team effort. This is our CRE team at PayPal. We'd like to open up for questions.
Zone is an availability zone, like.
It's an actual AZ, an availability zone. Yep.
It's not actually a no AZ, like it's see, there is an OpenStack instance running on that. And if it goes down, it does not affect any other OpenStack instances. Like there is a control plane, there is a data plane for each AZ. So it's an instance of OpenStack.
Many conductors, one group of APIs.
Yeah.
Can you repeat the question, please?
The question was, what is our
definition
of an AZ? And the second one was, do we manage with one ironic or many ironics? And we have many conductors and one API endpoint.
And yeah. That is actually another AZ, which we call infrastructure AZ, an OpenStack instance running to manage all bare metals.
Are there any other questions? Yep, I see over there.
So after you deploy a server, do you leave it using neutron networking, or do you flip it to use some kind of static route?
Neutron.
Neutron.
We have in-house modifications to Ironic that as soon as an Ironic port is created, it also creates a Neutron port at the exact same time, matches the UUIDs between the two. So given either a Neutron port or an Ironic port, you can find the other quite easily.
Okay, so you've got your, say, 12,000 physical servers all on a Neutron network?
Yes, we do.
I'm interested in you talked about using a configuration manager database. And in large organizations, one of the biggest problems is change management. So especially working between automated changes done in prod. So how did you negotiate that with your enterprise change team to be able to do all this automated stuff?
We just did it.
Okay, you didn't ask them or
Nope.
negotiate with them, you just did it.
We came up with the idea, developed a POC, and then presented it to them, and they liked it. And we went further and developed it into a series of applications.
How do you detect the anomalies? Do you actually have like a machine entity or a vendor relationship where you get the MAC address and the spec electronically in advance?
Nope. As soon as the machine is, the BMC is plugged into the network, it DHCP requests. At that point, we've captured the MAC address, IP, and vendor. And from that, we log into the machine, derive the details of that machine, and then post that back. Our CMDB will have information about the role the machine is supposed to take and the areas it's supposed to have access to. So we can compare that information. We can then monitor the link state on the data network port and make sure that it's up and it has the right address.
CMDB is already configured with an expectation of
What we expect the machine to be, yes.
For that, Or is it just you have a static operating model that you know every server is going to have X number of connections and you expect that?
Those are defined in the CMDB. So it will say, we do not define the BMC in the CMDB. We do indicate what its address is after it's been assigned. But we have a fairly static model of how our machines are connected.
So if you're looking for any rules engine, we haven't done yet. and to mention, like, two of the members here, Raj and Samir, with us, they can also take up the questions, any difficult ones.
Are there any other questions? Oh, over here.
How do you manage the upgrades? Do you have any outage or disruption to the clients?
Upgrades in what sense? Ironic upgrades or machine? We have redundant conductors in each availability zone, so we can take one out, upgrade it, and then in the overall process end up upgrading the APIs. So conductors first, APIs second, and we can roll through those, not interrupting the workflow.
Did you need to reboot those Ironic clients or just on-fly upgrades?
Just on-the-fly upgrades. Yes? We do not currently. I actually just had some conversations with some vendors yesterday about how we can start leveraging some of those capabilities. We've looked at RAID previous, and it wasn't ready for us to use. In conversations yesterday, we'll be taking another look at it and seeing if we can start leveraging that.
So that was the, how do you do the RAID right now with RAID provisioning a server?
Yeah, in a perfect world, they would come from the vendor configured as we ordered them. In real life, the guys racking and stacking the machines will actually configure the RAID for us. But hopefully that's going to be changing soon. Did I see a hand?
Just going to ask also, like, how you manage firmware. Is that sort of a post-stage after the node's enrolled?
Currently, that would be handled by the node enroll program, where we could deploy a RAID flash image, hopefully with some of the items that Ironic is looking to get into and standardize, that would be incorporated into the Ironic functionality. But right now, it is a separate image per vendor that's deployed onto the machines as part of the burn-in process, and the machine is brought up to what we expect it to be. But yes, hopefully that will be integrated into Ironic. It is a RAM disk that we've created. It runs Stress. It runs a couple other tools to just work all of the machines and all the components within the machine.
So it's not like you're not doing it through IK, you're actually doing it.
We're deploying an image to do it. And that image has abilities to post back to the Ironic conductor to update its own status in the node extra field. Are there any other questions? In the back? Okay, sorry, I can't see back that far.
Do you use any Neutron provider? Are your routers compatible with Neutron at all? Or do you manually create a whole networking stack?
Do we use Neutron providers? I didn't hear the whole question, I'm sorry.
Do you use Neutron providers for your routers? Like when you program Neutron ports, do they automatically get created upstream, or do you have a manual process to create those?
If I'm understanding the question correctly, we do have a networking team who creates the Neutron networks for us. And all we end up doing is creating the ports on the appropriate network for the machine. And then all of the machines deployed are deployed with a config drive so that the routing and IP information is within the config drive. We also include network information within the config drive. I see a question over here.
Did you get any pushback from DHCP on your DMZ network?
Absolutely not. It was in place when we got there. it's actually worked out quite well. I only have about 400 nodes in Ironic that don't know what their URL should be. But that's just due to legacy changes. Are there any other questions? Thank you very much.
Thank you.